Let's go.
Hello everybody. I hope everyone is fine. And today we are going to discuss two GATE 2024, not one. Today we are going to discuss two GATE questions. One will be completely from the network theory and another will be from the analog circuits. Okay. So here it has been said that there is a source of 5 milliampere. Now that 5 milliampere is flowing through here and then there is a 5, then the rest of the current is flowing through here. If you look into these two nodes, is the voltage value across this node, that is I naught into 10 to the power 3. So this is, you can say that 1000 I naught. This is 1000 I naught. And also, what is the node voltage over here? Here the node voltage is 10 to the power 3 into Ix. So between these two node, there is already a difference of 1000 I naught. So you can see that this one is 1000 I naught because it is I naught is flowing through the 1 kilo ohm resistor, and here at this point it is 10 to the power 3 or say 1000 Ix, and between these two there is this 1000 I naught. Okay. Unfortunately guys, there is a trick that if you see the difference, that there is a minus and there is a plus. Okay, so here if you see the equation, if you see about the equation, then this is your 1000 I naught and this is your 1000 Ix. So here it will be like 1000 I naught minus 1000 Ix, that is equal to minus of 1000 I naught, that you will get. So here you will get that 2000 I naught is equal to 1000 Ix. So your 2 I naught is equal to Ix. Okay, so 2 I naught is flowing. It's not, because Ix is equal to 2 I naught. So we can say that I naught plus 2 I naught plus 2 milliampere is equal to 5 milliampere. So 3 I naught is equal to, which is 3. So your I naught is equal to 1 milliampere. So your Ix is equal to 2 milliampere. So you can easily solve it. There is no need of KCL or anything. There is no need. Okay, you have to just follow the basics and then you will get the answer. Okay, but the trick was this one, that this one here there was a negative sign and there was a positive sign. Suppose it was interchanged. I'm just changing it. Suppose say it was interchanged, that this is plus and this is minus. I'm just saying. Then here it is already 1000 I naught, and here already there is a 1000 I naught. So then here cannot be any current which is flowing, because this node and this node difference, I mean this node, let me change the color, say this node and this node difference is equal to 1000 I naught, correct? But already there is a 1000 I naught drop, so how there can be any drop? So this node is nothing but a zero voltage, so then Ix will be 0. But here you have already seen that the polarity is already being, the polarity is different. Here you can see that there is a plus sign and there is a minus sign. Okay, so these are the questions which needs to be checked in GATE very seriously. And if you see this thing, and if you see that, yeah, I naught and Ix, through Ix there will be how much current? There will be a 3 milliampere current. And also if you can just find out that Ix is equal to 2 I naught, which we have already derived in earlier. So that is just only, you will need around say 60 to 90 seconds to solve this question, and it's a 2 marks question. Okay. Now let's discuss the second question, where there is an N:1 step down transformer and where it has been mentioned that the diodes are ideal. And it has been also mentioned that these diodes has no voltage drop in forward bias condition. It means that there is a zero forward bias cut-in voltage. Okay. So the input voltage is given as n sine omega t, and the DC average value of the load voltage is given as 2.5 by pi. So now we have to find the value of n. Before going to the solution, let's first see how a step down transformer works. And I should mention that in here it's a center type transformer. Okay, so if you apply a voltage of 10 sine omega t, then the voltage across the first half of the transformer is 5 divided by n into sine omega t, where you can see that the upper part is plus and the lower part, which is connected to ground, that is negative. Okay, and in the lower half of the transformer the voltage across it is 5 by n sine omega t, but the plus sign is connected with the ground and the lower node is connected with the negative. Okay, so when sine omega t is greater than 0, then you will see the d1 is forward biased, but d2 is reverse biased. How? Because if you see the upper part, the positive sign is already connected, the positive voltage or the higher voltage is already connected to the p terminal, so it will be forward biased. But in the lower half, you can see that the lower potential, the negative voltage, is connected with the p, so it is reverse biased, so d2 will not conduct. So entire 5 by n sine omega t voltage will appear across the VLT, I means the across the load voltage. And now if you calculate the average value, and you need to do time integration, and you can see that sine omega t can be greater than 0 only for half a cycle. So if you do an average for half a cycle, then what you are going to get, you will get around 10 divided by n pi. Okay, and it is given that 10 divided by n pi is equal to 2.5 divided by pi. So your n is equal to 4, and that is our answer. Okay, and one another thing, that is a paranoia check, or you can say that for sine omega t less than 0, my d1 will be reverse biased, but my d2 will be on. So when the d2 will be on, then again the sine omega t, then the VLT will equal to minus 5 by n sine omega t. Okay, so the main motivation to behind building this full wave rectifier was that in the sinusoidal wave the DC value is 0. You can't get a DC value from a sinusoidal waveform. But if you can do something like a waveform which is positive throughout, and you can see for the entire time range it is only positive, it can't go negative, then there is a possibility that you can give a non-zero DC value. And then if you can just filter it or just do some capacitor or something, then you can actually build a DC value, DC voltage. So you can even build a AC to DC converter from here.